this video, we're going to work on Spotify data analysis pipeline, converting this raw stream of data into this interactive dashboard. The best part, the whole pipeline is fully automated. Once started, every component runs on its own, from data ingestion all the way to the dashboard updates. We get the raw data, we stream it, we store it in data warehouse, which is Snowflake, then we clean the data in 3 stages, bronze, silver and gold, which is also known as Medallion Storage Architecture, and then we connect everything to Power BI to transform them into real insights. By the way, this pipeline uses modern data stack, Kafka for streaming, Minio for data lake storage, Airflow for orchestration, DBT for transformation, and Docker to containerize them all. By the end of this video, you will see how the data flows flawlessly from Spotify events all the way to visual insights, automatically, efficiently, and in real time.
Alright, let's begin with the architecture of our project. This is our data pipeline. Our data pipeline starts with the data source, which will be a simulator code written in Python that generates the data, which means we're not going to use any static CSV or Excel files, which comes with predefined data stored in them. We instead are going to use a simulator code written in Python that generates infinite number of rows. It totally depends on how long we run the code. It generates one row for every second, so it never ends. We use the simulator code instead of CSV because we want to make this project run in real time, so we don't want the data to be stopped at some point. The data should be infinite, so we use a simulator code for that. And the data coming from this data source, which is a simulator code, will be streamed using Kafka, will be encoded first and then streamed in Kafka, and the stream data will be then consumed by the consumer and decoded back into JSON files and stored inside the S3 bucket, which is defined in Minio. Minio is basically like a S3 bucket or a data lake. So the raw data will be stored in Minio first, and then the data from there will be transitioned to a bronze table that is stored inside Snowflake. Snowflake is our data warehouse, and this transition from Minio to bronze table inside Snowflake is handled using Apache Airflow, which is our orchestrator. All right, and yes, basically the data in the bronze table is raw. It's just the JSON files directly from the simulator code, the data source. This raw data will be then cleaned with some manipulations, and then this clean data will be stored in silver table inside the Snowflake itself. After that, this clean data will go through a few transformations like aggregation or grouping, and then this business ready data, the final business ready data, which has everything in them that we need to create visuals, will be then stored in gold table at the end in the Snowflake itself. This whole data processing will be handled using DBT, which stands for database transformation, DBT. So we're going to use DBT for the data processing, Snowflake for data warehousing, Airflow for orchestration, and Minio as our data lake, Kafka as our streaming engine, and the data source will be a simulator code, like I said. And all the tools that we need for running these, like Kafka, Minio, and Airflow, will be defined in containers using Docker. So the whole thing is run inside the Docker. This final business ready data, which is stored in gold table, will be then connected to Power BI. So we connect Power BI to Snowflake using direct query method, not import method, because we want to make this project real time. We are going to use direct query method, which means if the data in source changes, the visual also changes. But if you use import, it just downloads the static data from Snowflake, and the visuals won't change at all. unless you refresh it manually. But for direct query, you don't need to refresh. It just refreshes automatically when the source changes. And that's why we use direct query here to connect Power BI to our final goal table that is stored in Snowflake. Yes, with that, I think I explained the whole pipeline for now. To begin with, the apparatus required, the tools that we need are VS Code, Visual Studio Code, Docker, Snowflake, and Power BI. And the links for these 4 tools will be given in the description of this video. This will be the homepage of Visual Studio. You just need to click on download for Windows if you're using Windows. If you're using Mac, you need to download for Mac. And then this will be the page you land on when you click on the Docker link. Here, you just need to click on download Docker desktop, and you need to choose among which processor your PC actually has. If you're using Apple, choose between these two, if it's Silicon or Intel chip. And for Windows, if your PC has AMD processor, you need to go for this. Or if you have Intel, you have to go with this ARM64. And yes, so download and install with the default settings with them. And then for the Snowflake, this will be the page you land on. You need to create a free trial account. You don't need to put in any card details or any sort of payment methods. You just need to put in basic details like first name, last name, your email, and then that's it. They see if the mail is legit, and if the mail ID is legit, you'll get the free trial for 30 days. And they also offer $400 worth of free credits that we can use in this free trial period. And yes, that's how we initialize Snowflake. And then the 4th tool will be Power BI. By the way, Power BI, we don't use the latest version of Power BI because the latest version comes with a bug where we cannot connect Snowflake with Power BI using direct query method. We can connect both of them with import, but in our case, we need the data should be in real time. So we need to connect both with direct query method, but the latest version doesn't support direct query method connection between Snowflake and Power BI. And that's why we need a version that is older than August. But the link I'm going to give you guys will be the August version Power BI. So when you click the link, you directly download the file. You just need to install the Power BI. Yes, these are the four tools that we're going to use. We need to install them in our PC. Okay. Done with that. Let me close them. Okay. Now let's open the tools and see how they look like. All right. First, let's open Docker. Oh, it is already opened. And when you open Docker for the first time on your PC, it asks you for the sign up, but you don't need to sign up. It is not mandatory. You can skip it. You don't need to sign up to run containers. I myself did not sign up, by the way. And yes, any containers we run will be seen in this page here. Okay, now let's minimize this. We don't close it because we have some work to do with that. Now let's open VS Code. If you installed it with the default settings, like I said, this will be the home page that you will land on. We'll open our repository inside the VS Code and start working on it. Right now, we haven't created the repository, so let me close this as well. And the third tool I said is Snowflake. This is the home page for the Snowflake. Like I said, you'll get a 30 days trial period and with $400 worth of free credits. Right now, I already used $20, so I just have $380 of free credits left. You can use those credits within this 30-day period. And this is the home page for the Snowflake. We will use this as well. For now, let me close it. And yes, and also for the Power BI, we'll open it at the end. And for now, we have all the tools installed. Now let's create the repository. first. No. To create the repository, you can use the UI. You can just create the repository inside the folder here itself, or you can use command prompt, which is, which might be new in the beginning, but this is the easiest way and fastest and reliable way. You have more control over your actions when you use commands instead of the UI. So yes, let's create the repository first. dir. Hit enter. mkdir stands for make directory. This creates a directory, a folder inside the desired location. The location right now is users and the username in C drive. And the folder that I created is Spotify MDS project, which is just created in the UI as well. Right now it is empty. We haven't created anything yet, but we will. And that's how the commands work. So mkdir is for the folder creation, and then we use cd. Let's copy paste this. We use cd. Cd stands for change directory. To change the location that the command prompt is in, before it is in users and the username J. Right now it is in users, username, and our repository, inside our repository. So any action performed here will be reflected inside our repository now, which is here. Right now it is empty. Let's create a folder. Our first folder will be simulator, which contains the the simulator code that generates the data. Let me name it simulator as well. There you go. You see simulator right here. So we created a folder named simulator using mkdir. You know what? We don't need to do this from here, the command prompt. We can just use VS Code because we installed VS Code. We're going to use VS Code for to manage everything, right? To open VS Code, we don't need to open VS Code and click on the open folder and select our folder. We can just open from the command prompt itself, and it opens at the location that we are in. We are right now inside our project repository. So when we say code space dot and hit enter, VS Code opens with our repository in it already, which is Spotify MDS project. Right now it only has simulator as a folder inside. We will be adding the file, the simulator code file now. But let me close this command prompt for now. This one too. Before filming this video, I already done this project and also uploaded it in GitHub and named it as test Spotify MDS project. And I have all the codes here. So I'm going to take my code. But for the codes that you want will be given in a different repository, and the link will be in the description of this video, the GitHub link. You can get every code and every file, including the .env file as well. Okay, now let me get this. This is our simulator code. No, not this one. This is the consumer code. This is our simulator code, producer.py. Copy that code. Switch to VS Code. Close the other tab. We just need our repository. Here, let me create the file named producer.py. Paste it. Save it. If you take a close look, every variable inside the code is defined as os.getEnv, and you don't see any hard-coded variables inside the code because we will be using a .env file outside the code, so we don't expose these, sort of secrets directly into GitHub. So we use a .env file. The .env file is not in GitHub, but I saved it in my PC in the test. Yes. But for you, I will also upload the .env file inside the GitHub as well. So you can get the .env files from the GitHub directly. Let me open that. Copy this new file .env. Okay. This is our simulator code. Save this code right here. Before explaining this code, we need to create the containers first. So let's go for that first. For that, let's create another folder here. Name it Docker. Inside Docker, we need to paste the Docker code, the compose file. This is the Docker compose file. This composes all the containers we need. Copy that. New file. Docker compose .yml. Paste it here. Okay. Now let's see what we're doing in this Docker compose code, right? Firstly, we are creating a Zookeeper container. We need Zookeeper in order to run Kafka, and this is the main Kafka container creation, and this is Kafka, which is basically an user interface for Kafka. Without this, we cannot have an user interface, but we can still run Kafka without a user interface. So we need Kafka to actually have a user interface. And then we have Minio. Like I said, this is our storage location. A Postgres server. We need a Postgres server to initialize Airflow. This is Airflow init. This includes all the actions, the commands that we need to run to initialize Airflow. After we create Airflow web server and scheduler, we need to run, Airflow database initiate, Airflow database migrate, Airflow user to create username, to define the username, first name and last name, credentials basically. So we need this to initialize Airflow. And then we need this for the UI, Airflow web server, and we need this for the schedule. And like the name says, Airflow scheduler. And all these definitions have ports defined already. We use these ports to connect to that particular container. And for the Kafka, we use 9092, 29092, and for Minio, we use 9001, 9002. And the username and password will be defined inside the .env file. Like I said, we're not going to expose our secrets like credentials inside the code itself. We retrieve the variables out from the external file, which is our .env file, and we're not going to upload that to GitHub. So let's get that .env file as well. Like I said, the .env file is not uploaded into GitHub for me, but for you, I will be uploading that .env file as well inside the GitHub itself. You can get that from there. So for me, let me get that from here. Let's create the .env file. That's basically it. And for the airflow, we define the volumes where we put the DAG files. We define a folder named DAGs. And in this location, we put our DAG files, the .py DAG files, and then Airflow automatically detects these DAGs and run them. We need these three volumes, one for the logs, one for the plugins, and one for the DAGs. Yes, that's it with the compose file. Now let's fill the .env file. For the Minio root user, I'm going to use admin as username, and for the password 123. For the PostgreSQL, we're not going to use these credentials anywhere at all, so I'm going to say Airflow. I don't need to remember these as well. Let's say Airflow for that, and for the Airflow, we need these credentials. We need to remember, not the first name, last name, or mail ID. We just need to remember the username and password that we define here. I'm going to use the same username and password here as well. Admin and password 123. It's totally up to you. You can choose any username and password. And also for the first name, I'm going to say dev. ID, I'm going to say temp@gmail.com. Okay, password 123 admin. Save it. And for the requirements, we need to install a few modules to run the simulator code, and also all the codes that we need to run. We need these requirements, and these all required installations are listed in the requirements.txt file that you can find in the GitHub itself. This is the requirement.txt. So we need all these tools to be installed before running anything. Let's create a file, name it requirements.txt, fill those details and save it. Now we need to install these requirements first, and then we need to run Docker, and then we need to run the simulator code, and it will work. Firstly, head to the terminal option on the top, click on it, click on new terminal. This opens the terminal. Here, like I said, we use cd to change our location, change directory. Cd, we need to go inside the Docker folder here, because our Docker compose file is inside the Docker. But we don't need to go inside the Docker yet. We need to install the requirements first, like I said. So we use cd space double dots dot to go back one folder. So we go to the root repository now, which has the requirements.txt. Now we need to install. To install, we say pip install. Wait a minute. So this list doesn't include Python. By the way, you also have to install Python on your PC. Remember that, because this list doesn't include the Python in it. So you need to install Python, and then you need to install requirement.txt, and that's it. So we use -r, which is a flag to read a file. We use that. Say requirements.txt. Hit enter. This will install all the requirements that we need to run these files. Successful. Okay, we're done with the installations. Now Let's compose the containers. Let's hit cd docker. Now we are inside the Docker folder and we need to run this docker compose.yml file. For that, we need to run command as docker compose -f and our file name, which is docker hyphen compose.yml. And at the end, we need to say up to open the containers. To define and open the containers, we need to say up at the end, and to close these containers, to stop these containers, we need to say down at the end. Now we are defining and opening the containers, so we say up and run it. You can see it says created. By the way, when you run this command, you have to make sure the Docker desktop is running in the background. Only then this command will run. So Kafka drop Airflow, and right when you see Airflow DB initialized successfully, this is your confirmation, which means you have to see the containers running in the Docker desktop. By the way, this container alone stops because it only has to run at the initial stage of the Airflow because it needs to initialize the Airflow. So it runs at the beginning and it stops after a few seconds of running. So you don't need to worry about that. It needs to be stopped. Okay, and the rest of the containers should be running. To make sure they're actually running, you have to open calf drop for the Kafka. To open that, you need to click on the port. It automatically redirects to the browser. This is the Kafka UI basically. So Kafka is working, and then our next tool is Minio. Click on the port. Minio is working. See if the credentials are actually working. Fill in the credentials that you defined in the .env file, which is admin for the username for me and password123 for the password. There you go. And that works. And the last one is Airflow. You need to click the port at Airflow Web Server. Like I said, Airflow Web Server is the UI for it. The UI for Airflow. You need to click on the port next to the Airflow Web Server and put in your credentials. Hit enter. There you go. Now we confirmed all the three containers are actually working. Okay, now Kafka is running, so our next job will be to run the simulator code. All right, like I said, we created 3 volumes, remember, for the Airflow, the DAGs, logs, and plugins. You should be able to see those volumes created inside the Docker right here. So any DAG file for the Airflow will be should be saved inside this DAG folder, and logs will be created by Airflow here, and plugins will be empty now. Okay. Yes, now we're ready to run the producer code. Before running the producer code, we need to understand what kind of data this producer code is actually generating, right? So because we need to know the data in order to work on it and clean it. So let's have a good idea of what data we are working with here. To comprehend the data we are working with, we need to understand this code, like I said. And this, at the beginning, we import the modules that we are going to use in the code in the future, in the code blocks. But for now, I'm going to tell you about these 2 modules, import OS and this one from .env, import load.env. We need these 2 modules to load the variables from .env file, which is saved externally outside this producer.py in .env file. So we need those 2 modules to import those variables. And then we define the .env here using this line. These rest of the modules will be expanded further I will explain them further. And here we're defining the configuration for the Kafka. First, we start with the Kafka bootstrap servers, which will be the port number that we need to connect to Kafka to stream the data. And this here we refer to OS, like I said, OS module, which we imported, and get env, and it directs to this variable, Kafka bootstrap server, which is saved in the .env file, which is this one. So this is the port that we need to connect to Kafka to send the data to it. So that's the server name, and then this is a Kafka topic that we create inside the Kafka where the data is, streamed. So we need to create a topic inside, and the topic name is defined in .env, which is by default Spotify events. You can change it. It doesn't matter. It's totally up to you. Yes, that is the Kafka topic, and user count. Here we use int of os.getEnv of user count, comma 20. So we point it to user count in the .env file, which is user count is 20. But if the variable is not defined or it is empty, then it goes to this 20. So 20 is like a default value that we assign to it. So if the variable that is specified here is empty, go with this, the default value 20. And then it has event interval seconds. We need to, like I said, we need to define the time delay between each row generated. And here in our case it will be 1 second. So it waits 1 second before generating the new row for every loop. And here as well, we first refer to this variable, which is defined in the .env. If it is empty or it's not defined, then it goes to the backup variable that we are backup object. No, the backup input that we gave, which is the default value 1. And then we define the faker with the variable fake. This is a producer. Here we assign the variable producer with the Kafka producer. Kafka producer has the bootstrap server, which is the port number that we already defined at the top here. We call that. Then, like I said before, streaming into Kafka, we need to convert this data into bytes. We cannot directly stream the JSON files in Kafka. So we first convert lambda v. So it chooses one object at a time, lambda v. And JSON.dumpSof. JSON is the module that we imported at the beginning here. JSON.dumpSof method converts a dictionary into a JSON file. So there is JSON dumpsof and there is JSON loadsof. JSON dumpsof converts a dictionary into a JSON file, and JSON loadsof is the other way around, which converts a JSON file into dictionary. Here it converts a dictionary into JSON file. And then this converted JSON file will be encoded using UTF-8 format to stream in Kafka. And that's it. Here we define the producer. Next, moving on, we have a list of dictionaries which has artist and song pairs, and we named it the variable as song artist pairs. Artist is The Weeknd, Blinding Lights, and the song is The Blinding Lights, and artist Dua Lipa, and the song is Levitating. And we have 3 unique artist and song pairs. So right, you can add more if you want to, but these are the ones that I used. So yes, moving on, we have a for loop. We created this for loop to assign to generate a unique song ID for each of the song. So it takes for pair in song artist pairs. So it takes one single pair at a time from song artist pairs. Let's say first it takes artist The Weeknd and song Blinding Lights. Now the next step would be name for UUID. This is a variable. And by the way, UUID. If you don't know UUID, which we imported here, the module UUID. UUID stands for Universally Unique Identifier. It creates a unique identifier every time. But UUID4 creates a unique identifier every time, but UUID5, there is UUID5, which we are going to use here, that creates, you know what, let me go there. First, let me explain this line first, all right? So we created this variable, named for UUID, and we used fstrings. If you don't know fstrings, fstrings is used to create a string with dynamic objects inside. So in this fstrings, the only static part is these two double columns, but the rest of the parts, the pair of artists is dynamic. It gets the artist name for the given pair. First, for the first time, for the first loop, it takes the weekend in this place. So the weekend double colon and pair of song, which is blinding lights. So the output of this f strings for the first loop will be, let me just copy paste it like this. So this will be, what am I doing? So this will be the output of first loop of this. The weekend double colon blinding lights. For the second loop, it goes like Dua Lipa double colon levitating, and so on. So it creates a string like this. Why? Because we want a unique song ID, but anytime this function iterates, it should give the same song ID. So that's why we're not going to generate a random ID, but we will generate it using namespace DNS, using UUID5 here, pair of song ID. So we are creating a song ID and assigning it to this particular object, and a string of UUID5, UUID.namespace DNS. Like I said, we are going to use that, and name for UUID. So any ID that is generated here is totally dependent on this variable. So this string, if you give this pair again, it creates the same ID again, which means no matter how many loops you, how many times you loop it, the same song ID assigned to the same song, because it is not, it is not static. I mean, it is not random ID. It is defined from the string that we created here, the artist plus song combination. We use that to make it unique and also assigned, distinct for particular song. And yes, we're done with that loop, and then we define 3 lists: one for the devices, one for the countries, one for the event types. Firstly, for the devices, we have mobile, desktop, web, and for the countries, we have US, UK, Canada, Australia, India, and Denmark. And event types, we have play, pause, skip, add to playlist. The next one, user IDs. We are going to create a list of user IDs, and the number of user IDs, the number of unique user IDs it is going to generate is totally dependent on the user count that we defined in .env. By default, I defined it as 20, which means, to compare between the users, I just defined 20 unique users. So it will be easier for us to see what's actually happening in the user engagement. So I just created 20 unique users for that application, which is Spotify. Here, this is the variable name, and in the list, we define string of UUID.UUID4. Like I said, UUID4 is used to create a random universally unique identifier, and we use for loop here, and the range is user count, which means this outputs 20 unique user IDs and lists them and assigns the list to the variable named user IDs. Okay, we have the user IDs list now. And heading to our main function, we define the function name as generate events of first pair equals random.choice of song artist pairs. So it chooses, we use random module that we imported at the beginning, import random. So we use random here, random.choice of picks a random objects in a given list, which is song artist pairs. So it picks a random object, which means a random dictionary, and each dictionary is a pair of artist and song. So it picks a random dictionary from this given list. And then user ID here, it also uses the random.choice of, which picks a random user ID from the given user IDs list and returns. This function returns event ID as string of uuid.uuid4, which, like I said, a random unique ID every time it loops. And for the user ID, it already picked a random user ID from here, so it assigns to that. For the song ID, it is also picked here, so it assigns to that. And for the artist name, from the picked randomly picked pair, it chooses the artist name. And for the song name, the same from the pair. And for the event type, random.choice of event types. Like I said, a random object from the given list, which is event types, play, pause, skip, add to playlist. And then the next one is device type, random.choice, that's random device from the given list. And for the country, random.choice, a random country from the given list. Timestamp, we use datetime.utc now, the current time, which is in universal, which is the universal time, and then we convert it into ISO format. That's why we imported time. Where is it? Date time here. We used it. Okay, we're done with the main function. Moving on, we have this. If name equals main. This is to make sure only to run this if this program is the main function. I mean, this program is the main of that, of the compiler. You cannot call this program, you cannot call this function into another program and run that there. It should be the main program. So we do this condition for that to check whether it's a main whatever program it is, and then we print start Spotify data simulator just for the debugging. If this prints everything from here, now everything at the top is working fine. If this gets prints, everything on the top is working fine, and then we print f strings using length of song artist pairs, songs, and length of user IDs, users. Okay, here we print the length of song artist pairs, which is 6 right now. So we print the list of length of this list, and also we print the length of user IDs, which is 20 by default. Like I said, f strings is used to create a string with dynamic objects in it. And this part using and songs and users, this is the static part of the f strings, and these length of song artist pairs and length of user IDs is the dynamic part. The dynamic part is always defined with flower brackets at both the ends. So this dynamic part starts from here, ends with the closing flower bracket. And we have for loop P in song artist pairs, and it prints which song and which artist and the song ID is generated for that particular loop, which will be assigned to that row in the data. And while true, we use while true method to loop to loop infinite times unless we interrupt it by closing the terminal totally, or we can hit Control plus C to interrupt it. So unless we interrupt it, this loop is going to run infinite times, like I said, to make it real time. And event equals generate event, which refers to the function the main function that we define at the top, and then we have producer.send Kafka topic comma event. So it sends the generated data, the row, to Kafka to stream, and then it prints produced event type, song name, artist name, user ID. So it prints everything. And then time.sleep of event interval seconds, and here we use time module. Remember, we imported time at the beginning, so we use that module here. So event interval of seconds, this is the variable that we define in .env, and that is 1 second by default, and it's totally up to you. You can say 2 seconds or 3 seconds, whichever works with you. And yes, event interval seconds, we define it here to delay the loop, to create the records. If one record got created, it waits for 1 second or whatever seconds we define, and then it loops again and creates another record. So the time delay between the record creation is 1 second basically. Now let's run the simulator code to generate the data. For that, let's open a new terminal. That new terminal, head to the simulator folder. Now we're inside the simulator folder where the producer.py file is saved. Here we need to run Python producer.py, hit enter. Now it says, so it lists all the songs, like I said. Here, because of this, it lists all the songs and artists and the song IDs assigned. And at the top, because of this, it prints the length of the artists and the user IDs, which is this, using 6 songs and 20 users. And then here, because of this, it prints the event type, the song name, the artist name, and the user ID, which is these. So it prints what song and what event and what artist and what user ID is generated. I mean, which combination is generated. So right now, the data is getting generated, which means we should be able to see this data in our Kafka topic. Let me open Kafka real quick. Just calf drop. That's the topic we created, Spotify events. In this topic, we should be able to see our data. Now it says 94 as size. When we click on all messages, it displays all the messages that got generated. And every message has event ID. Event ID is the unique ID, user ID, song ID, artist, song name, event type, device type, country, timestamp. Everything works fine, which means we are done with, let me go to history, open the message chat. So we are done with the first 2 steps, which is initializing our data source and streaming the data on Kafka. So we're done with these 2 steps. Now heading to our third step, we need to consume the data out of the Kafka stream and then save it in Minio, which is our S3 bucket. For that, let me pause this for now. Let me pause this. Like I said, we need to hit Control plus C to interrupt it. Only then we'll pause the stream. So I'm going to pause it. Now we need to create another folder named consumer. This should consist of a new file. Let's name it Kafka to minio.py. And I have the consumer code, in the GitHub repository itself. This one. Copy the code into the VS Code, paste it, save it. We also need, of course, a .env file. For the .env file content, we need to, well, I need to. You guys don't need to go to this. You can just find the .env file as well in the repository link I gave you. But for me, I have to get that from here. Paste it. Save it. Okay. To begin with the consumer code. This also imports the module that required to run this code, which includes these two modules, import OS and import load.env, just to refer the .env file variables. And the rest of the variables we'll see when I explain that particular code block. Right? Okay. And this is to define the .env, and then this whole code block is the configuration for the Minio. And the first line defines the bucket name of the Minio. And right now the bucket name is set as Spotify. You can change it according to your wish. Right now I named it Spotify. And then Minio endpoint, which is the port it needs to connect to, communicate with the Minio storage, and Minio access key and Minio secret key. Minio access key is the username and Minio secret key is the password that we define here. Oh, no, not defined here, but that we predefined when we created the Docker, which is admin and password123 in my case. And next we have Kafka topic, which is Spotify. I think it's Spotify events and Kafka bootstrap server, and that is host docker internal 29092. And then we have Kafka group ID, Spotify consumer group. You can name it anything you want, but if you name the group ID and run that consumer code once, and if you want to refresh that group, the consumer group, you need to change the name, or you can delete the consumer group totally. Either way, it works. If you're not familiar with the groups of these consumers, I'm going to explain it right now. I think in this code block, I will explain it in that code block. And the batch size defines how many records should be combined into one batch and create a JSON file. Right now it is defaulted to 10. You can change it according to your convenience. The batch size is defined as 10 for now. batch size determines how many records should be recorded before converting those records into a single JSON file. In our case, 10. So it waits until the 10 records, 10 new rows enters into the consumer. It waits for 10, and then when it gets 10 new rows, it converts those 10 new rows into a JSON file and store it in Minio. So it stores as batch of 10 rows. One JSON file has 10 records in it. And that's why we use JSON. That's why we define the batch size here. And then we have Minio configuration. S3, Bodo 3. We use Bodo 3 module, which we imported from here, to connect to Minio. And .client S3, like I said, it is like an S3 bucket, Amazon S3 bucket. Minio is something similar to it. Endpoint URL, Minio endpoint URL, which is this port, localhost 9002. And then we have AWS access key ID, which is the user ID, and this is the password. You can see it says AWS access key. It acts exactly like, more closely like an AWS S3 bucket, but not exactly that. It don't store the data in cloud, but it stores the data locally in our folder itself. But it acts like an S3 bucket. That's why we use Minio. If you have access to AWS, resources, you can use S3 bucket directly here instead of Minio. That one, either way it works. We just need to store the data somewhere, right? So we use Minio here, and then we have this one. We have try and exception. So it tries to check s3.head bucket equals bucket Minio bucket, print bucket already exists. So it checks if the bucket already exists in Minio. We can create it manually inside Minio. Oh, I haven't opened it. Yeah, we can create the bucket manually inside the Minio. Let me show you how. Let me open Minio. Here, we can click on create bucket and name it and hit create bucket, and just like that we will have a bucket. So we can do that, or if you don't create a bucket, the code creates a bucket itself using the exception. In exception, we define s3.create bucket with the bucket name that we defined, which is Spotify in my case. So it creates a bucket named Spotify and prints created bucket. So we use these two prints to debug. If there is any error, we use to debug that. And also we know that bucket is created or bucket is already existed. So we print those two. And then we have consumer. We define the consumer here, which is Kafka consumer, which we imported the module. From Kafka, import Kafka consumer. Use Kafka consumer here. And the bootstrap server is host docker internal and auto offset earliest. There are a few methods for the offset, which is earliest, and there is newest, and there is oldest, I think. So the earliest picks the data from the beginning. No matter when you run the consumer, it picks the data from the beginning of the Kafka topic. Let's say right now we already ran the producer, so we already have a few records, right? So when we run the consumer, let me see, I think we have the records close to 100. So when we start the consumer now, it don't start to save the records from 101. It starts from the first record. It starts from 0. So it don't start from 101. It starts from the beginning of the data. So that's why we use earliest. I mean, not particularly beginning of the data. It depends on the offset. If you stop the consumer, it saves the offset. The offset, when I say saves the offset, it saves the point where it stopped. All right. Let's say, oh, we have 163 messages, by the way. So if you stopped at 14th record, right, and we restart the consumer again, it won't start from the beginning again because it says earliest. It starts from 15th. So that's why it saves the offsets all the every time it saves the data, it saves the offsets, and it continues where it stopped. And yes, and that's why we use earliest here, auto offset reset earliest, and we use enable auto commit. It commits, that is set to true, and the group ID is where the offsets are saved, not the data but the offsets. If we reset this group ID, let's say I run the consumer with this name, Kafka group ID, and I went through 10 records, I saved 10 records, and then I changed the group ID as something different to the initial one. 1, 2. So if I add anything to that, I mean, if I change the ID, the whole offset will be started over again. So if I run the consumer with a new group, consumer group ID, it starts again from the beginning of the data. So that is where the offsets are saved, in this group ID. Like I said, the encoded data should be decoded again when we save that to Minio. And this is where it happens. Value deserializer, lambda v, JSON.loadsoff. Like I said, JSON.loadsoff and JSON.dumpsoff are two opposite methods. One is used to convert dictionary into a JSON, and the other one used to convert JSON to dictionary. And here it converts JSON to dictionary. And decode format will be UTF-8. And it prints listening for events on Kafka topic and the topic name. This is the dynamic part of the print statement, f strings. Now we create an empty list with the variable name batch, right? And we open a for loop for message in consumer, which is this. So it gets a message from the consumer, one single message. Event equals message.value. So it just takes value. So the messages that are in the consumer has not just have the data, it also have the metadata. I mean the time constraints and we shouldn't call constraints. You know, the metadata like time, the ingestion time, the extraction time. So all that metadata should be avoided by doing this message.value. So it only takes the value that we send to the Kafka. So it only takes the value here. Then batch.append of event. So it appends to this list, that particular record to this list. If length of batch is greater than batch size is what we defined in the .env, which is what? Right now it is 10. It's totally up to you. You can say 20 or 30. So right now it is 10. So it waits only if the batch size is greater than the defined batch size, the length of batch is greater than batch size, then this will be executed. Now equals datetime.utc now. The current time will be saved, assigned to this variable now, then date path now.strf time. This is the formatting the time, year, month, day, hour. So we formatted the time. And the file name, we're going to use a custom file name. We designed the file name ourselves, and file name is dynamic. It depends on the time that particular record is saved. In this case, f strings, this whole part, Spotify events, is static, but this is dynamic. Now.strftime, so that captures the present time, where now is the date time.utc here that we defined. Now.strftime, it formats this .json. So it saves as Spotify events and the present time.json file. And that's how we make the file name dynamic according to the time, and the file path bronze slash. So bronze will be the folder inside the bucket, the main folder, and the subfolder will be the date path, and the file name will be the defined file name, and the subfolder will be the date path, which is this. So you will see when we're on the consumer, I'll show you how exactly the folders are crafted and the data is saved. Okay, so this is all about formatting the data and the names of the file name and folder names. And here JSON data equals new line join JSON dump of E for E in batch. Like I said, JSON.dumpsof converts the dictionary back to a JSON file. S3.put object bucket equals bucket name that we already defined, which is Spotify, and key equals file path. So here is where the file path is defined, which is this one we defined before. Body equals JSON data.encode of UTF-8. And then it prints uploaded length of batch. Length of batch, of course it is 10. So uploaded 10 events to Minio, and it shows the file path where that particular 10 records are saved. And it empties the list again at the end because this needs to be iterated again. So it empties the list again, and this process iterates from the beginning with an empty batch variable. I hope I articulated this explanation in the right way, but if I haven't, I'm sorry, I tried. Okay. That explain the consumer code. Now we need to, define the credentials. Admin. And the password is password123. Password123, and then that's it. That's it. Now we already have the data, so I don't want to run the simulator code again. Go back a folder. Just happened. Okay. And then open cd consumer. So we're inside the consumer folder right now. To run that consumer, say Python and copy this file name, Control C, paste it here, .py, run it. It is listening for the events now. There you go. Because we have around 160 records, so it created 16 JSON files. Like I said, the batch size is 10, so 163 records comes to 16 JSON files, and the rest of the remainder, the 3 records will not be saved for now. It waits for the other 7 records to approach, and then it converts to another JSON file as a batch of 10, and it will be saved in the consumer. And yes, if we count this, we'll see 16 outputs here because it created 16 JSON files. So that ran with no errors, which means we should be able to see, if we refresh this, I haven't created the bucket, remember, but the code created the bucket by itself named Spotify. And then the folder name. I said I'm going to tell you guys about that when I run the consumer. So I'm going to say inside the bucket, the first folder, the main folder name is bronze, right? Right here, bronze, the file path. Inside the bronze will be the date, which is this date path, right? And then the third one is hour equals 11. Wait. Oh yeah. Oh, this one, hour equals 11. So it says date equals, and also the hour. So there is two subfolders inside the bronze. And inside this, we should be able to see the JSON files. Okay. But I think I did a mistake. So it took batch of 10 to save, but it saved in same, oh, okay. So the number of JSON files created is not dependent on the batches that we get. It depends on the time. So all these batches are created on the same time frame, right? So they all be added to one single JSON file. And the last three are on a different time frame, which is at 43 seconds. So those three are saved in a separate JSON file. So there are only two JSON files. So it was my mistake explaining it wrongly. So the number of JSON files created is not dependent on how many batches we are getting, but the time frame that batches are saved. So if it is this time frame, it will be saved in this JSON file, and if it's this time frame, it is saved in this one, which is, so this is the date, so this is the time, 11, 44, and 42 seconds. And anything after 42 seconds, which is 43 seconds, are saved in this JSON file. So that was my mistake explaining it. Yes, the number of JSON files is dependent on the time frame and not the batches that we get. Okay, that is clear. And it stopped here. So we should only have saved 160 records and not 163. But that's fine. So we have the data in Minio now. So we're at this part. Now this part is done. Our next part would be pulling out the data from the S3 bucket and saving it into the bronze table inside the Snowflake using Airflow orchestrator. Let's do that. To do that, we're going to we don't need to create a folder, but we only need to create a file here and name it something like minio to Kafka. .py. Let me get the code. Docker dax. There it is. Save it here. And obviously the .env file. But the .env file, let's get that from this folder. Docker dax.env. Copy that. Save it. We imported all these modules, and of course these two for the .env file, and the rest I'll explain it to you in the process. Yes, this is defining the .env, the path here. Because we are running it in Airflow, we cannot just leave it as load.env off like the other codes. We just use this because this is running locally on our PC. But here we are running this in Airflow, so we need to define the path where the .env file is actually saved. So we define the path here. Next, this is the Minio configuration endpoint, which is the port that needs to be that we need to connect to get the data out of it. And then we have access key, which is the username, and the secret key, which is the password, and then Minio bucket is the bucket name, and Minio prefix, which is a file name. We have this is a Snowflake configuration. Snowflake user, the username, Snowflake password, Snowflake account, which is, if you open Snowflake, every Snowflake account has a unique identifier, and you can find it by clicking on this one on the bottom left and click on session details. And here, Snowflake context, this particular block is the unique identifier of your account. This should be copied and pasted at Snowflake account, which is this one. So that particular part should be copy pasted here. And the username and password and the account we have. And the warehouse, you can find the warehouse name at compute, click on warehouses, and you'll see the active warehouse that is running. Right now, everything is closed, but mostly it will be compute WH. So by default, I put compute WH here. And we have Snowflake database. We haven't created any database yet, but we will. And we have Snowflake schema, which is bronze, which we also haven't created yet. Snowflake table. We can create, or we don't need to, because in our DAG file, we define the process to create the table by itself. So we don't need to create the table. We just need to create the schema and database. And yes, the local temporary path. We define this path because we need to save this particular files. When we pull the files out of the Minio, we need to save those files temporarily somewhere in the PC or any of the storage space. But here, in this case, we save them in our personal PC temporarily. So we define this path where to save the files. And then this is the function. This is the function to extract from Minio. And the next one, this function is to load raw data to Snowflake. Firstly, to extract from Minio, this is, we don't need to do this. This is just a string, we can just ignore it. And the next one, this is the configuration, S3 Bodo 3 client. We use Bodo 3 to connect to S3 bucket, which is Minio in our case. We are not using AWS S3 here. And yes, we're defining the configuration just like the consumer code. And the response, S3.list objects, bucket name, prefix, the prefix where the JSON files are saved. Contents, response.get contents, so it gets the contents in the prefix. This just creates an empty list with the variable name as all events, and it opens a for loop where it gets one object at a time from the contents, and then from that it assigns the objects to all events list here append. So, and it uses JSON loads. Like I said, JSON loads is used to convert a JSON file into dictionary. So it converts the data into dictionary, the JSON files, and then it appends to the list, which is all events, that is the empty list. So it appends all the, all the rows to this variable, this list variable. And then except if there is none, this will be printed. And there is with open local path, so it opens the local path and then it dumps again. It again converts it into a JSON and then store it into the local path. And from there, it takes the data out of that temporary path and then loads to Snowflake. While loading the Snowflake, so this is where it defines the path, and then open path, JSON.loads off, which converts the JSON again into dictionary. If not events, print no events found to load. If there is no events, print no events found, just to debug, just in case if the tag didn't work, it at least prints this if there is no data in it. And then this is the configuration for Snowflake. It includes username, password, account, warehouse, database, and schema, cursor, and connect.cursor, and it creates a table. Like I said, if we don't create the table, the DAG by itself creates a table if it doesn't exist, and it also defines the columns in it. Event ID is string, user ID is string, song ID is string, artist ID. Everything is string initially. Timestamp is also string initially because it doesn't allow, the Snowflake doesn't allow us to define the timestamp while we ingest it into Snowflake. So we need to define it as string. Later we'll convert it into timestamp when we clean the data from bronze to silver. For now it is just string. And then this, so first it runs this command, use database, which is Snowflake database that we haven't created yet, we will, and use schema, and it uses this schema that define, and then create table, runs this. So it runs this query inside the Snowflake and it creates a table, and inside the table created, the data will be inserted using this query, insert into Snowflake table, event ID, user ID, song ID, artist name, song name, event type, all the columns. Initially they are all strings in the bronze, but we will convert them again. And here for events, in events, execute insert SQL, so it inserts everything inside the table. And yes, after everything is loaded, this will be printed, loaded, length of the events, length of the rows basically, and this is the static part. Row records into Snowflake table and the table name, this is the dynamic table name. We're defining the DAG here. This part is the airflow DAG definition, and we're defining the DAG here, owner as airflow start date. We define a start date, and I'll say why we define the start date. All right, and we have retries, which is right now, which is 1, and retry delay time delta equals 5 minutes. Retries are for the DAGs that fails. If the DAG fails, it retries, and how many we define how many retries are allowed to that DAG. Right now it is 1. So if it fails, it retries again. And if it fails another time, it just says the DAG failed. So it tries 1 time. Logically, it tries twice. The first one, and because of the retry, it tries again. So it tries twice. And the delay between the retry is 5 minutes. So if it fails, it waits for 5 minutes before it retries. Okay. And by the way, this date time should be in past. If you define this date time as in future, the DAG starts running only when this date time passes. So it should be in past or present. So make sure about that. And then we have with DAG. This is the DAG name that will be displayed in Airflow UI. Default args. These are the arguments that are passing to it. Description. It can be anything. We're just describing the DAG. Schedule interval, hourly. So the DAG schedules, the DAG runs every hour. We can say day, so it runs every single day, once every single day. Now it is hourly, so it runs once in every hour. And here we define catch-up as false. When I told you to save the start date, if we define this date as yesterday, if we turn the catch-up as on, this DAG runs 24 more times, because we say catch up as true and the start date time is yesterday, so it is already lacking 24 hours, so it runs the DAG 24 times. Here in our case we say catch up as false, so it won't run no matter what a date it is. If it is in past, it runs one single time when we start the DAG and then runs it again after an hour. I hope you got it, but I tried my best. So let's say this date time is 24 hours prior to today. If the catch-up is true, right after we turn the DAG on in Airflow, this DAG runs 24 more times right away. It won't wait for, it won't run hourly. It just runs 24 times right after we start running the DAG. So we have to do catch-up as false in order to overflood the Airflow. That's why we say catch-up as false. And as DAG, extract track, Python operators, task ID, and Python callable extract from Minio, which is the function that we defined. Extract from Minio. So it calls this function and then this function in the second task. With the task ID as load raw to Snowflake, Python callable load raw to Snowflake. This is the function, this is the next function we defined. Provide context true. And this is a sequence of the task execution. First, it executes extract task, which is this one, this task ID, and then it executes load task, which is this one, which basically is extracts from Minio. First, it extracts from Minio the raw data, and then it loads the raw data to Snowflake. So that is how the sequence works. And just with that, we're all done with the DAG. Now we just need to configure the .env file with Minio username, which in my case is admin, and password is password123. Okay, and this I already put in my account number, account ID. For the username and password, I'm gonna stop the recording and resume it after I put in these details, because they are the actual credentials I'm using. Okay. Have the tag, and we also configured the .env file with all the credentials. Now, if we open Airflow web server, log in, password 123, sign in. Let me delete this. Shows my old DAG file, so I want my new one. So I'm going to refresh that. And also, let me delete the catch. Logs. Okay. So you should be able to see the DAG file right away in post or all. To play it, no, we cannot start it right away, because remember, we have to create the database and also schema inside the Snowflake. Let's do that. And the name of the, I'll written my credentials in the .env, so the name of the database should be Spotify DB, because we already defined in this .env file. Let's open a new SQL file. Exit here, say create database, paste it, run it. Database Spotify DB successfully created. When you see that, you should be able to see the new database inside the catalog, Spotify DB. And in this database, you have to create the schema. To create that, you should make sure you're inside your database that you created, Spotify DB right here. And here, you run the query, create schema. And the name of the schema is bronze. Run that. Create schema bronze just now. So now we should be able to see the schema inside. You need to refresh. There you go. Now the bronze schema is also ready. And we don't need to create the table. That is not mandatory, because our DAG file does the job. Well, so we're going to resume the DAG file. Okay, like I said, it runs right away. So if it says running here, that means the DAG is actually running. And if there is any failure or success runs, you can see that here, right here. And because we have two tasks in this DAG, it says 2 are successful in here, the recent tasks. And we click on this success and click on here, we see our tasks listed here. The first one is extract data, where we define the DAG as extract data. Define the task as extract data. It basically shows the task ID, extract data, and load raw data to Snowflake. So they both are successful. So in case if you face any error, you can debug that by clicking on here. If it is successful, it says green. If it is failed, it says red and says fail. In this, I think in here. Either way, if it is failed, you can click on that failed bubble and click on here, and this will show exactly which task is failed, and click on the failed task, and these extra options will be visible. All right, and now click on the logs, and here you'll see the exact reason of the DAG failure. If you face any problem solving the error by yourself with the logs, you can just copy this whole thing and paste it in any AI. Either it is Gemini, ChatGPT, or Perplexity. Either way, you'll get the solution. So this is how you debug any error that is faced in the data file inside Airflow. Here are the logs. You just need to copy paste it into any AI and the AI gives you the solution. In our case, both the tasks are successful, which means we should be able to see the table created under the bronze schema. Refresh that. So it shows the table here, and we click on it and switch to data preview. Right here on top it says 20 rows. Click on preview. Here's the data. So the data is already created here. I mean, the data is saved here. Now we have the data inside our Snowflake, which means we're done with this step as well. Now we need to convert the data from bronze to silver and then to gold, which is done by DBT because that is our data processor. Before going into DBT, I just found out something. We just got 20 records here in Snowflake, but in Kafka, we have more than 160. And this happened because we ran the consumer after we ran the producer a few seconds, which caused this error. But if you don't want to get this error, all you need to do is you need to start the consumer first and then run the producer, because here the JSON files are created with the time frame. So if I run the consumer after generating, let's say 100 records, all those records are consumed on the same time frame, right? Which means one JSON file is replaced with another. So only the last JSON file will be saved, which is this one. So we in order to avoid this, we need to run the consumer first and then producer. Let me show you in practice. All right. Here I'm in the consumer page. I'm going to run the consumer again. So I'm going to start the consumer first. Okay. Now it is running. We don't have any new records yet, but now I'm going to generate the records as well. Python producer.py. Now, because these records are generated one for every second, there is no chance one JSON file is replaced by another one, because you see, so this file is created at 50 seconds and this one is created at 28 and this one at 28:10. So every JSON file is 10 seconds apart from each other. So there is no way, because of the file name, they get replaced with the new one. So that is how we need to fix that. We can fix that. That is what lacking before. And that's why I just got 20 records in my Snowflake bronze table. But if I do this and run manually trigger the DAG again, I'll get the latest rows inside the Snowflake. So yes, if anyone found this error, this is how we tackle it. Well, we just need to run consumer first and then start producer. So I'll just stop it, just not flood my PC memory with these data and also the Snowflake. So I'm going to stop the stream. But we should be able to get the records, the new records. You see, now we are getting everything. Now we have 100 new rows. No, not new rows, 80 new rows, and 20 rows are already in there. And also for the JSONs. hour 12. You see? So one JSON is created for every 10 seconds now. So that fixes the, the glitch. Okay, now we have this. Heading to DBT. Let's create a new folder for DBT. Name it Spotify DBT. And in the terminal, change directory Spotify DBT. So we're inside this folder that we just created, and here we initialize the DBT. We already installed DBT with our requirements, so we don't need to install it again. DBT core and DBT Snowflake. So we don't need to install that again, but we need to initialize it. We run DBT init. Extend this. Okay. Enter a name for your project. I'm going to enter Spotify DBT again. Okay. Now it asks to select an option. Of course, we're going to use Snowflake, so I'm gonna enter 1. And it asks for the account, and it also says the value that it needs. So we have to take the account again from the session details. The same part that we did in the DAC file. We need to use the same thing here as well. Enter and username and password. Put my username. Choose any of the authentication type, password, key pair, or SSO. I'm going to go with the password. So even if you enter the password, it don't show you here because of the obvious security reasons. But you just need to put in your password and hit enter. And the role should be account admin. You can find the role in Snowflake itself, by the way. Here it says under your username, it says account admin. That is our role. So that's what I put in here. And the warehouse name is compute WH. And the database name is Spotify DB and Spotify DB. And for the schema, we already named this schema as bronze, but using the same bronze schema name as for the silver and the gold doesn't make any sense. So we're going to create a new schema just for the transformation for silver and gold. So let's create that. Open the same notebook. I'm just going to edit this because I'm already inside the database, our database. I'm going to name it transform. Select that line and run it. Transform successfully created. You should be able to see that schema transform. I'm going to fill that in here. Transform. Yep. Hit enter, and the threads depends on how fast your process needs to be done. Depends on you. I'm going to say 3 threads. We don't even need 3. I would say 1 is just fine because we're just going to do 3 transformations, 1 for silver and 2 for gold. So we don't need that many, but it is what it is. Yes. After that, it says Okay, if you see this message, that means you successfully initialized DBT, which creates the logs and our project named, a folder named our project, Spotify DBT, which I defined here, Spotify DBT, a name with a project, a folder with the project name that we defined will be created under here, and it has all these folders created: macros, models, seeds, and snapshots, and logs as well. Okay, we have the DBT initialized now. We need to do the transformations. To do the transformations, let me just collapse it. Extend the models. You will see a few models already created, which is under example folder, but we don't need example folder. So we're going to delete the example folder. We don't need it. Now under the models, I'm going to create a source first, a new file, name it source.yml. So we need to define where to get the data from first. So we're going to say for the source name, database as our database, which is Spotify DB. And for schema, our source schema, which is bronze, where our bronze data is present. And for the table, Spotify events bronze. That's it. And here we create a new folder named silver, another folder for gold, a folder named gold, a file inside silver named Spotify silver dot SQL, because it's an SQL file. Now we're going to get the data from the bronze and then clean it and store it in a silver table. No, a silver view. By default, DBT creates views, not tables. If you want to create a view in particular, you need to define at the beginning of the code saying materialized equals table. But we don't need to go for the tables in particular. We can go for the views. So I'm going to leave it that way and create a view. In case you wonder what the difference between a view and a table, A view doesn't save the data to itself. It refers to the source every time to refresh. I mean, but the data is up to date. Let's say if I create a view that refers to a bronze table, the bronze table. So if any data in the bronze table changes, this view automatically updates the changes, but a table won't update it. I think I messed up. Let me say it clearly. All right. If we create a view, let's say here, which is Spotify Silver. So the name of the view will be Spotify Silver here, right? So if we create this view refers to the bronze table, which is Spotify Events Bronze. So because this is a view, that if the data changes in this bronze table, the changes will automatically reflect in this Spotify Silver view. But if we create a table instead of view in this place, the Spotify Silver, if uh, if we do that, the changes in bronze table will not automatically reflect into bronze table unless we run this DBT transformation again. But you might say, if view updates itself automatically, why is there even a table separately? Because they both have their own merits and demerits. Views updates automatically, like I said, but if we want to query anything from views, it takes a long time because it needs to go to the reference and get the data from that. In our case, if we query anything from this view, it goes to the bronze table and gets the data from there. It needs to, refer to the bronze. But in table, it just refers to itself because it saves the data to itself. When we query something from that table, it is relatively faster than the view. And that's why in few cases we use tables and in other few cases we use views. It depends on the situation and the scenario we are in. But for now, we don't actually care about the speed. So we can just use view here because it updates automatically, and it also, reduces a process. If we create a table, we need to create another DAC file to refresh the table periodically. But for the view, we don't need to create the DAC file because the view is updated automatically. And that's why we are creating a view. I tried my best to explain. Okay, here, select event ID, user ID, song ID. Its name, song name. Event type, device type, country, timestamp. And for the timestamp, we do Okay. Here, we don't have much cleaning to be done because the data is generated by ourselves. We define the data. So we don't have any cleaning to be done, but I just included a few basic cleanings to be done, which includes changing the timestamp into an actual timestamp from string. Remember, we just stored the data in bronze as strings. So we transform that string into actual timestamp using this line. So this whole thing in SQL is called as CTA, Common Table Extension. We use this to do functions like this. So it is like a temporary table that we create, then we refer that table using select and the table name. So this is a temporary table name bronze data that we created inside this code. This table will not be saved anywhere. It's just created temporarily while we execute this code. So it selects everything, and this is the source that we already defined here, and this is the schema name, and this source table name. And when we also make sure these columns are not null, well, there is no way our data will have null columns for these four: event ID, user ID, and song ID, and events. But because we generated the data, but in real world, this is a best practice to to filter out. So it shouldn't have any null data in these columns. So yes, these are the basic cleaning steps that we need to process. Okay, now that is done. Now from this, we need to create the goal transformations. So because this project is about Spotify, we're going to create a goal table just for the interactions for the song, to see which are the top songs and the song performances. So we're going to create a table just to track the song performance, and another table for the user engagement tracking. We're going to create two goal tables here. Okay, let's do that. Open a new file. Song ID. Song name. Here, we're just selecting song ID, song name, and artist name. Okay. And then we count where case when event type equals place. We are counting only the place here for this column. And we say when event type equals place, then 1. And it ends, the loop ends. And the total number of ones will be counted using count of. So it only counts the place and adds them up, aggregate them into one column, and that is called as total place. And this column counts only the skips and aggregates them, and the total will be assigned to total skips column here. And the reference is from Spotify Silver table that we will be creating. I mean, Spotify Silver view, by the way. And we group by these 3, the song ID, song name, and artist. So here's the rule in SQL. The column should either be in the aggregation or be in group by. So the column should be in any one of these 2. It should be aggregated or it should be in the group by. Because we only use these 2 for the aggregations, the rest of the 3 columns should be in the group by. So that's why we use these group by. So we group the data with these 3 columns and we aggregate the rest. Aggregate these event types into these columns and assign to them and order by total place. So the song with highest place will be at the top and followed by the descending order. So these we are ordering it in descending order. Okay, that is done with the top songs table. And now let's create another table. Let's name it user engagement, user engagement. .sql. For the user engagement, we need everything related to the user here. Let's do that. Select. User ID, comma, device type, the country, now kind of case copy paste it. This should be for skip. Name it skips. This should be for add to playlist. Playlist. Date from date. given ts as day. Like I said, if the column should be either in aggregate or group by. The rest of the columns, user ID, device type, country, and day should be in here. User ID, device type, country, we paste this. And order by, place, descending. Okay. Yes. Here it captures all the user engagements, including play, skips, and add to playlists. And like I said, if the column is not aggregating, it should be listed in the group by. And there are 4 columns that are not aggregated, which includes user ID, device type, country, and day, which are included in group by, and then ordered by descending according to place. We have all the transformations ready. Now let's run them. Now we're inside Spotify DBT. We're inside the folder, but not inside the project. So we have to enter into the DBT project. Again, we need to run Spotify. Let me turn caps lock off. CD Spotify DBT. Now we're inside the project, the DBT project. Here we can directly run DBT run and hit enter. Well, we got an error, and okay. It says the error is that ref is undefined. I think it should be sources. Oh, here. Shouldn't be in capitals. Something with this. Okay. Anything else? Oh, there is an other error at here, song ID, because it says right here, invalid identifier sound ID. It should be song ID. Right, the song ID is also fixed. Now let's run that again. DBT run. Okay, the first one is successful. Well, all the 3 are successful, which means we should be able to see all these 3 views listed in Snowflake, and under the transform schema, there you go. And we should be able to see the data here. If you take a close look, the timestamps here, this is just a string right now. We converted the timestamp into an actual timestamp in this silver table, and that's why it shows. We can clearly see that in columns, I think. Yeah, in columns. You see, even TS is listed as timestamp, but whereas in the bronze table, the columns should be here. It is listed as watch hour, which is not, appropriate. We converted that in our silver table, and now it is actually timestamp. Yes, we have the data here listed correctly in silver, and for the gold, perfect. We only, like I said, we only, captured the song performance here, and we have six songs and six artists, and these are the total plays for each song and total skips for each song. User engagement. So we created 20 users and we grouped everyone with the country and the device type. So we should have multiple records, not just 20, more than 20, because we're grouping it with user ID, device type, and country. So we will have multiple records created. But with this user on mobile, there are 3 plays. And with this user on mobile from UK, there are 2 plays and 2 skips and 2 add to playlists. Okay, now our data is all ready, which means we successfully completed 90% of the project. But at the end, right here now, we just need to connect Power BI to Snowflake and create a dashboard for the Spotify analysis. That's the only step left. Let's do that. Again, remember to download the Power BI from the link that I sent you and install that. And uninstall the new version, uninstall the one that you have on your PC, and then install this one, all right? Or else the latest Power BI will fail to connect to Snowflake using direct query method. But if you're fine with the import method, you can use the new Power BI as well. But if you want the direct query method, it should be the old version. The new one will fail. It has a bug. So the link will be something like this, right? Right after you click the link, it downloads directly. It won't ask you, it don't ask anything, it just downloads the file. And after it is downloaded, you just need to install with the default settings, right? Because I already installed it, I'm gonna cancel it and open Power BI on my PC. Get data from other sources. Scroll down a little bit and click on Snowflake. Hit connect. Here for the server name, go back to Snowflake again. Unlike the DBT and Airflow, we just use this part, right? But in Power BI, we can use the total, the whole thing, but not the HTTPS, but the rest of the thing. And still, Power BI can connect to it. We need to put in the warehouse name, compute WH, click OK. If you're doing this for the first time, it opens, an authorization page where you need to log in with your Snowflake credentials, but I already logged in, so it didn't ask me. From here, click on our database, transfer our 2 gold tables that we, 2 gold views that we created. Click load. And here, if it is the new version, like I said, if it is the new version, it fails to connect when we click on direct query. But this is old version, so it should be able to connect. There you go. Now we have the data in Power BI and it is direct query, which means it is in real time. Okay, now let's create the dashboard. Let's create a few KPIs first. For the KPIs, I'm going to choose total place, not sum of place. Should be, or is 40? Is it 40? (11 plus 11, 22, and 22 plus 9, 31, 36. Yep, we have 40 place. So this shows the total place. So we have a KPI for that. And another KPI for total songs. We can choose song IDs, either way it works. And we have to choose count distinct. Well, they are distinct, but still. You can choose count distinct. What happened? Okay. Count distinct. And another card for total users. User engagement. User ID. Choose count distinct. By the way, we only defined 20 users, right? But we got 31 because remember when I stopped the producer code and then rerun that again, you should not do that because every time you rerun the producer code, it creates 20 more new users. So it created, I think the second time I ran, it created 11 more users and yes, I got 31, unfortunately. But if you run the producer once and you don't rerun it, you will get 20 unique users here. But for now it's 30, that's fine. Basically, let me show you. Before when I tested it, I created a dashboard already and I already got 20 users in it. I'm not sure if I can open it because I use direct query. It says cannot load model. Yeah, well, I cannot. But yesterday I got 20 users. Because today I ran the same producer twice, it created, uh, more new users, and that's why I got 31. It should be 20, basically. If you run the producer continuously without stopping, you will get just 20. You should not rerun the producer. For now, I'll just leave it for now. And for the total artists, another card for the total artists, count distinct, 6. Okay. I think that's it for the cards, and let me save this with name Spotify analysis. And we can create a map using country. And also, by the way, if you are using maps for the first time on Power BI, you should enable an option. Let me show you which option it is. You have to go to options and settings. I think it's data source settings. No, sorry. Options and settings, options. Here under global, under, no, I forgot which one it is. Yep, under global, under security, this will be by default turned on. Turned off. You have to turn this on and click OK. Only then you can be able to use the map chart. If you have to turn that option on, then you can use this chart. We just have the map right now, but let's add something else to it. Let's add place as bubble size. Okay, now it shows which location has more place. Right, let's keep that aside. Now let's create a bar chart. Not for this one. New bar chart, and for the bar chart, artist name, total place. Good. And filter them using artist name. Now using total place. Now in the artist name, I have to go to top N. Let's filter out top 5. I think these two have the same value, 2, 2. Well then, in that case, let's filter out top 4. By value. Did I do that? Top 5 and top total place. Apply filter. I know it cannot because these two has the same number of place, 2 and 2, so it cannot take anything out. All right, let's leave it and go to the donut chart. For the donut chart, let's create one for the device type and total place as values, and another donut chart for action. All right, that's it. I think that's enough. Here, let's take out the legends for these two donut charts, and also turn off the headings, the details label, the title. This one too, for this one too, for this one. Perfect. Let's switch the theme to dark. View and let's switch to dark theme. Go to canvas. Let's choose this, map settings, style dark. Make it dark. Auto zoom off. Now click on anywhere on the canvas, not on the charts, anywhere on the canvas, and switch to this, canvas settings. Now, canvas background, for the color, I have a color code saved for the background. It's 333 basically. So, yep. So that matches. Wait, it did not. Okay. For the rest of the charts, let me take the background, turn off the background for everything. All right. Okay, we have that. Bubbles. And for the colors, gradient. What field should we base on? Sum of place. Lowest. For the highest, I have a color code already. I have the Spotify color code for that. Let's use that here. Let's use the same color code for that, but lighter. Something like this. Perfect. Do the same for the bar chart. First, let's take down the title on y-axis. We don't need that, and x-axis title. Total place. be bold. And for the bar colors, effects, gradient, total place, same color code, same thing for that, but lighter. Okay, good. No legends. Let's insert the icon inside this image, open, paste it here, and also paste the text. Spotify. Size of it, go 80. Perfect. And for the color, the same color code. That's good. Effects, turn off the background. That looks good. And then map is not blended into the background because of the padding. Choose the map and go to properties, padding. Zero here, zero here, zero here, zero here. Now, yeah, now it is blended perfectly. Okay. We have that ready. We have the bar chart ready for the donut chart. Change the color coding. Choose anything. For the first color, I'm going to choose the same Spotify color. And for the second one, I have another color code for that. This one. Paste it. And for the third one, perfect. Same for this one. Choose Spotify for one and this one for the other and this one. Perfect. And for the data visibility, data labels, just need category plus percent of total. Same for this one. Category, percent of total. Perfect. Let's resize this so it fits perfectly. And also for the slicer spacing, just increase this a little bit to make it look good. Okay, so let's copy the same settings for this bubble chart and also the properties, size, height and width. and also the position. Let me just position this right first. Okay. Vertical position should be the same. That looks good. Now we need to format this right. Right now it says decimal point. It has decimal points in it, which doesn't make any sense because that's the count of the place which won't go to the decimal points. So we need to format it right. Switch to data format. Format. Select whole number. There you go. Perfect. Size is something like this. And this. Position it here. We need to put the titles for this. I'm gonna say place, bold, align it to center. Great, and same for this. Total songs, bold, align it to center. Same for this. Total users, align it to center, bold, perfect. Same for this. Total sales, bold, align it to center. Okay. Now, shape and position one KPI at your desired location like this. Now copy paste these measurements, the properties and the position to the other KPIs so they align in the same line with the same size too. I'll copy the height first for everything. Like this, and now for the width, paste it, paste it, paste it. Now position, the vertical position, at 280, yes, 280, 280, 280. For the horizontal position, we can position it manually, that's fine. Okay. Now it looks good, right? Let's add one more thing. Let's insert a shape. Let be this one. Be something like this. Go to style, color, choose the Spotify color. Okay. Now choose all these KPIs. Click Ctrl plus X and Ctrl plus V so they come on top of this object. Now place this object on top of these. Click anywhere on the canvas. Now they're on top of that. Now that looks good. Save it. I think we're done with everything. Not yet. We just need to name these two down a chart. To name this, let's name them dynamically, statically, not dynamic. So name it action taken, action taken, bold, align to center, size it that way, and effects, turn off the background. from there. Okay. Place it right there. Now copy that. Come on. Okay. Rename it. Device place. Make sure they're aligned correct. Yep. Now we're done. Everything. Yep, that's it. Okay, I think it's time for the outro. Before we go to the outro, we need to, have an overview of what we have done just now. So firstly, we define the data source. Like I said, you just have to run the data source, the producer.py, once and leave it. You should not rerun. If you rerun, you will end up with this issue. You'll get more users than you defined. And we have the data source. We streamed it using Kafka, and then we pulled that out from Kafka using a consumer code and stored it in S3 bucket in Minio. And from there, the data then pulled out and saved in bronze table inside Snowflake, which is our data warehouse. And this transition from Minio to bronze table is done using Airflow as an orchestrator, and the DAG file is written in .py. And from there, this bronze table is cleaned and stored in silver table, and then this cleaned silver table gone to a few transformations, and the final business ready table is stored in gold. And this whole data processing is done by DBT while the data is stored in the data warehouse, which is Snowflake. And this final business ready data is then connected to Power BI using direct query, and then we created a dashboard that is live, that refreshes with the source. And with that, we're officially done with our project real-time Spotify analysis pipeline. I will be back with another video, perhaps by next week. Until then, see you. Adios.